Hello guys, thanks for watching my video. Today let's see another eta function, okay? Dirichlet eta function, okay? We are going to prove that the double integral from 0 to 1 of negative log of xy to the power s minus 2 upon 1 plus xy dx dy is gamma s eta s, okay? And eta s is nothing but the sum from n equal to 1 to infinity of negative 1 to the n minus 1 upon 1 to the s, okay? This is the definition of eta function, okay? So now let our integral to be I, then is double integral from 0 to 1 negative log xy to the power s minus 2 upon 1 plus xy dx dy. Now putting xy equal to t, so we are going to take y as constant, okay? Y dx is dt. You get 0 to 1, so this is for y, okay? 0 to 1, and for x, when x is equal to 0, so t will be 0, and when x is equal to 1, this will be y, right? Negative log t upon 1 plus negative log t to the power s minus 2 upon 1 plus t into dx is nothing but dt upon y dy, right? So this is integral from 0 to 1, integral from 0 to y, negative log t to the power s minus 2 upon 1 plus t dt into dy by y, okay? Now we are going to use IBP, integration by part, okay? Now, integration by part, treating this as a first function and this as a second function, right? So first function, this one is this one, integral from 0 to y, negative log t to the power s minus 2 upon 1 plus t dt, and integration of second function, then is integration of 1 over y is log y, right? So log y from y equal to 0 to 1, negative integral from 0 to 1 of this one, so the derivative of this one with respect to y is nothing but negative log y to the power s minus 2 upon 1 plus y, okay? This will be follow from the fundamental theorem of integral calculus, okay? Then is d by dx of integral from 0 to x f of y dy is nothing but f of x, okay? Then is the fundamental theorem of integral calculus, okay, using this one. Now log y, right? So here if you put here 0, so 0, right? So integral from 0 to 0 is just 0, right? When you put 1, so log 1 will be 0, so the meaning this whole term will be 0, right? Now we are left with this term only. I is, so this one negative, I'm going to put it here, okay? Integral from 0 to 1 negative log y to the power s minus 2 upon 1 plus y into negative log y dy, right? So these two have the same base and this one power is 1, right? So using the exponential law, then mean same base, power different, and they are multiplied, they mean power must be added, right? So integral from 0 to 1 negative log y, so s minus 2 plus 1 is s minus 1, right? Upon 1 plus y dy. Now putting that negative log y is x, so y is e to the negative x, so dy is negative times e to the negative x dx, right? So I is integral from, if you put 0 here, so there will be negative infinity, right? Log of 0 is negative infinity. With this it will be positive infinity, right? And if you put 1 here, so log 1 is 0, so it is 0. And negative log y is x, right? X to the s minus 1 upon 1 plus this y is nothing but e to the negative x, and dy is negative e to the negative x dx, putting here, right? And because of this negative, this upper and lower limit of this integral will be changed, okay, interchanged. So then is integral from 0 to infinity x to the s minus 1 upon 1 plus e to the negative x times e to the negative x, this one, okay? Now multiply both numerator and denominator by e to the x, okay? Then you will get I is integral from 0 to infinity x to the s minus 1, and these two multiply will be 0, no, e to the 0, then is 1, right? And these two multiply, so 1 time e to the x is e to the x plus e to the negative x times e to the x is e to the 0, which is 1, so it is 1. And from the previous video we calculated this one, then is gamma s eta s, meaning our integral I, then is this one, then is the double integral from 0 to 1 negative log of xy to the power s minus 2 upon 1 plus xy dx dy is gamma s of eta s. Okay, that's it.